Welcome back, and now it is finally time to find function inverses for ourselves. Rather than verify or talk about properties related to them, here's how we do it, okay? Procedure, it's kind of plain, it's boring, but we can talk about it. We're going to replace f of x with y, so just to eliminate the function notation, okay? And then what we want to do is do algebra, and instead of having y isolated, we want to have x isolated. Okay, so isolate x, get x alone. And then what we're going to do is interchange x and y, so where x is, we write y and vice versa. And then lastly, instead of y, we write f inverse. Okay, so let's see in a couple examples. Okay, so here we go. I'm going to do step one, write y instead of f of x, so y is equal to 4x plus 3. Okay, and then okay, from here you're going to isolate x, so get x alone, so y minus 3, and then divide by 4x, and then divide by 4. Okay, so y minus 3 all over 4 is equal to x. Okay, and then now, so this is step 1, this is step 2. Step 3 would be to interchange x and y, so I would write x where y is, and y where x is, so I get that. And then fourth, I'm just going to say instead of y, I have x minus 3 over 4. I'm going to write f inverse. Okay, so boom, done, quick. Okay, and really, if you think of the inverse function, it's really doing the opposite of everything that the original function was. And so mentally, you probably could have done f mentally, right? Like if you wanted to say, okay, well, if you want to undo what you did, right, you instead of adding, subtract, instead of multiplying, you divide. Okay, that one's easy to find mentally. G of x, on the other hand, not so easy to find mentally. Okay, so we're going to follow the same procedure. Y and x minus 2 over x plus 2. Now, how in the world do you isolate x, right? You have two of them. Okay, well, let's do some algebra. So cross multiply, okay, or multiply by the denominator. So you have x plus 2 times y is equal to x minus 2. And then, well, okay, this is going to get messier before it gets prettier. So let's distribute. We are not violating any algebra yet. X minus 2, okay. And again, my job is to isolate x, so I want to get x's to one side, right? So I'm going to move this over and move that over to the other side. So because then I'll have all the x's on the same side, minus 2y minus 2. Oh, now I can factor out an x, and then y minus 1. Okay, this is looking good. Minus 2y minus 2. Okay, and then I can isolate the x now. Oh, yay, we're almost done with this one. X is equal to minus 2y minus 2, and then divide by the y minus 1. Okay, yay, we got it isolated. Then interchange. Y is equal to minus 2y minus 2 over y minus 1. Okay, try that again. Back up. Start over. Minus 2x minus 2 all over x minus 1. Okay? And then finally, inverse symbol. Okay. Now, okay, and then we're done. Okay? Now, the whole reason we're having you do this process instead of what the book says is that this process is going to allow you to resolve any domain issues, which we'll talk about more in the next video. But it comes really into play with this next example. So I want you to get started on finding the inverse function for both of these. Okay, get as far as you can and then resume the video when you're ready. Here's my worked out answers so far. Now I will tell you that technically when you're doing these, you've made mistakes. Okay? Because if we think back to when we were talking about injective functions, right? Inverse functions need to be injective. They need to be one-to-one. They have to satisfy the horizontal line test. Does h satisfy the horizontal line test? No. But yeah, we can find an inverse, right? The thing is, in order for it to have an inverse, we need to restrict the domain. So you might remember that this is a parabola with a vertex. So the vertex is going to be at minus 1, comma 2, right? Since it's in vertex form. So then what we need to do for it to be 1 to 1, we need to look at 1/2 of the parabola, so from the vertex to one of the sides. And so maybe the easiest thing is to say we're going to look at the right half, so when x is bigger than or equal to -1. Okay, so this domain restriction is absolutely critical for h, and it actually plays out in the inverse a little bit. So and that's why this method of solving then switching is really beneficial. Okay, right here. Okay, notice that when we undid the square, right, we square rooted and we needed the plus and minus. So I need to make sure that x is bigger than or equal to -1. How do I do that with this inverse function, right? So, well, -1, if I were to add something to -1, right, it's going to be larger than -1, right? And the square root can only be positive. Okay, so that's why this is the inverse function is going to be forced to be the positive square root, because if it was minus square root, then I would be making -1 smaller, which would be the other half of the parabola. Okay, so then that forces each one of these to be plus and plus. Okay, so be aware of any domain restrictions that you have. It's needed for it to be injective, but it also plays out in finding the inverse function. Similarly here, we just maybe want to make the note that x is bigger than or equal to 3 here. Okay, it's cool, but not really of any importance. Okay, but what we notice when we find the inverse function is we get a parabola, right? This parabola has two sides, right? That is not an invertible function, right? Because it's not injective. So which half do we look at? Well, that's where we need to do a little bit of thinking. We know that originally, when we look at k of x, y, right? This whole thing, since it was a radical, that whole thing was greater than or equal to 0, right? So then, when we get down here to this x squared, what this is going to happen, or what this is going to force, is that if we look at the parabola, we're going to only get the part where x is bigger than or equal to 0. Okay, we'll talk about this more. It's connected to a property which we discuss in the next video, so just be a little bit patient on this. Okay. So the other thing that we can see here is that really when we get to this point, we're saying that y has to be greater than 0 all along, and then since we interchange the variables, right, later on we replace x with y, or y with x rather. So since y was originally greater than 0, x has to be greater than 0. So that's another way you can think about it right now. But the easiest explanation comes in the next video. Okay, so inverse functions, we have this nice standard procedure: isolate, and then isolate and switch. And then we just have to be careful with some of them when we don't have that injective property immediately. So make sure to be careful with the domains.